So for the Calculus 2 class, I wanted to do another example. This is from 9.8, number 25. The last example we did, the radius of convergence was infinite, okay? And because of that, we weren't able to do this endpoint test. And this one has a finite radius. So let's look at how to go about this, okay? So again, it's a ratio. I'm going to use the ratio test, yes? So I need a limit as n approaches infinity of the absolute value of this thing, yes? Now, when I take the absolute value, okay, what's it going to do? Let's look at this real quick. Remember, n starts at 1, so n is always positive. So, this thing, if x is less than 4, okay, and n is odd, it could be negative, right? Okay, down here the bottom is always going to be positive, right? But then we've got this thing here, which is going to flip and alternate. Okay, so we've got this absolute value, and the absolute value will take care of all that problem, right? But it's going to make this term here ineffective, basically go away, okay? So we're going to have x minus 4 to the n plus 1 over n plus 1, 9 to the n plus 1, okay, times n, 9 to the n, over x minus 4 to the n. Okay, so that's ratio test, right? Now we said that we need to cancel some stuff in order to make this work, right? So let's rewrite these things a little bit, make it a little bit more obvious how to cancel. Yeah? Okay, so x minus 4 to the n plus 1, that's x minus 4 to the n times x minus 4 to the 1, because when we multiply, we add exponents. Down here, we've got n plus 1. And then again, 9 to the n plus 1, that's 9 to the n times 9 to the 1. Okay? And then we leave this here. Just like that. Okay, so now we can cancel this and this, pretty obvious, this and this, okay? And we end up with absolute value, n plus 1, that's what's left after our cancellation. Now, n is going to infinity, okay? So with this polynomial here, we just can delete the terms of lesser degree, okay? So these things can basically cancel, okay? Since n is going to infinity, right? So what we end up with is, actually, when the n's cancel, we don't need the limit anymore because there's no more n in our expression, right? So when we take the limit, what we end up with is the absolute value of x minus 4 over 9. And what the ratio test says is that this converges, okay, when this thing is strictly less than 1. Okay? So where does that happen? Well, let's see. 13 minus 4, that's 9, okay? And what? Negative 5 minus 4, that's negative 9, right? So it looks like if x is between negative 5 and 13, right, then this is going to be true. So this is where this thing is going to converge, okay? as long as x is between -5 and 13. So that is a radius of convergence of what? 9? So the radius of convergence is 9. Now, the interval of convergence is a different story, right? So for the interval of convergence, we're going to look at two special cases. Those two cases being the endpoints. Okay. So what happens if x is -5? Okay, so we're investigating this, right? If x is -5, then we end up with this. Right? Okay. So this is -1, n plus 1. This is going to be -9 to the n over n, 9 to the n. Okay? So this is actually correct? And this can cancel. So what we end up with is this. Now, we can add exponents, right? When we multiply, we add exponents. So n plus 1 plus n, that's going to be 2n plus 1 over n. So this is the definition of an odd number, right? When n is 1, you have 3. When n is 2, you have 5. When n is 3, it's 7, right? So this is always odd. So this is always negative. This is the harmonic series, which we know diverges, right? So this thing diverges. The divergent harmonic series. So we know that our interval of convergence is going to be -5, and we're going to have an open bracket here. Okay? Now the next one we're going to have to do is going to be x equals 13. That's going to give us -1, n plus 1, 13 minus 4, the n, n, 9 to the n. 13 minus 4 is 9, so this is 9 to the n over 9 to the n. This cancels, and we end up with -1 to the n plus 1 over n. This is the alternating harmonic series. Which we know converges. So the other side of our interval of convergence is going to get a square bracket showing that when x is 13, the series converges. So here's an example that includes this endpoint analysis, all right? Now notice that I evaluated one endpoint, and then I erased everything, and then I evaluated the other endpoint, okay? Also, I used some discipline in plugging this thing in and not making any assumptions, okay? That's important, I think, to keep everything straight, okay? Because one endpoint, whether it converges or not there, has nothing to do with whether it converges or not at the other endpoint. They're two separate analyses. So hopefully this helps you going through some more of these problems, okay? If you run into anything that you get stuck on, please feel free to send me an email. I'll try to make a video to answer